Hi, this is Professor Jessup, and I'm doing a little lecture on Introduction to Linear Functions. Linear functions are commonly understood as lines. We're going to use a x positive to the right and y positive up coordinate system. I'll pick a point over here. Let's call it 1, 2, 1, 2. So this is going to be minus 2 and 2. And we'll call it point A. And then we'll choose another point to the right, and we'll make this point on the x-axis is 3, and the y-axis we'll call it just 1 up. So when we look at these two points, and we'll call this point B, we recognize that from A to B is a distance, and that's the first thing we'll approach, is that from point A we have a movement in the x direction of 1, 2, 3, 4, 5. So we see that its run is 5. And in the y direction, we see that we have gone down from 2 to 1. So it has fallen. So it's fallen 1, or the rise. The rise is negative 1. When we look at these run and rise, we notice that because of the nature of the axis having a 90-degree central angle, that as you move from, let me choose red here, as you move from A to B, we have created a, and choosing blue, sorry about that, but I'm a little bit new with this. We've made a kind of cumbersome right triangle. So the hypotenuse of that right triangle, which would be the measure of AB, or AB segment, is going to be the run squared, 5 squared, plus the rise squared, minus 1 squared, or negative 1 squared, and 25 plus 1 would be the square root of 26. That being our distance from A to B using the Pythagorean theorem. Another thing that might be interesting for us is the midpoint between A and B. When we want to look at a midpoint, let's get rid of the distance. When we want to look at the midpoint, we can say that the midpoint, and let's choose black for the midpoint, that the midpoint is going to be the average of the x's. So we have midpoint being the average of the x's. So we would have minus 2 plus the 3, and of course averaging two numbers, you would divide by 2, and the average of the y's, 2 plus 1 over 2. So we see that we have the midpoint is going to be 1/2 and 3/2. And that's sometimes interesting to know. Note that this point 1/2, 3/2 is approximately here, and that it is definitely on the line as a point that exists on the line AB. When we want to look at what that line appears to us as a function, and again erasing the endpoint and midpoint information, would want to look at a standard equation for it, and let's do this in blue. And this standard equation that we're going to use is called the slope-intercept form, and what it stands for is the slope is going to be the rise over the run, and the intercept is going to be this spot right here where the line hits the y-axis and x is 0. So the slope-intercept form we say is y equals the slope m, the rise over the run, times the x value plus the y-intercept b. So to find this equation, we simply plug in our information and solve for b. See, we have point A, minus 2, 2. We have point B, and indeed we also have the midpoint. So we have three different choices for x and y, and I'm going to choose point B. So I know that y is 1, and that the slope, the rise, minus 1, the fall, right, over 5. And of course I know that my x for the value of y being 1 is 3. So I have to just solve for b. And I'm going to do that using my standard solve any equation steps, and putting my 5 outside. I see that I have 5 equals negative 3, because the 5s obviously make 1, so minus 1 times 3, negative 3 plus 5b. So that when I add 3 to both sides, and I'm going to have to move this smaller over here, but when I add 3 to both sides, I end up with 8 equals 5b. And of course that means that b is 8/5. So with b being 8/5, and again unfortunately I'm not going to a new page but erasing, with b being 8/5, I then have an equation that looks like y, because that's the value that's being predicted by the x, and of course my slope never will change for this line. It's minus 1, it's a fall of minus 1 for every run of 5, is minus 1 times the x value plus my 8/5. That gives me an equation of a line that is actually a function, and so I could actually say the function of x that is y is going to be given by that equation.